In this demo, we're going to show you how AIMMS multi-objective optimization technology can be used to evaluate competing trade-offs in your supply chain. So in this screen, we see two competing trade-offs model. The one is cost. So for the supply chain, there's a total cost of 191 million euros. And there's a carbon objective measured in units of measured ton. And in this supply chain, currently the emissions are 6.2 million tons. And in this first optimization, you can see over here, we've included in the objective the total cost, the taxes, and the inventory. So these are euro numbers. And for now, we've left out carbon emissions. So in this optimization, we're optimizing for cost, and the carbon emissions are resultant. So this is the one extreme, a minimum cost network, and what's the impact on carbon. The next scenario we can run is to say, well, let's optimize for carbon and not optimize for cost, but just report on cost. So now I'm going to run the scenario by clicking on the Optimize button under the AIMMS logo at the bottom right here. And we'll let the mathematical optimization figure out what's the best in this particular scenario. So that scenario is now solved, and we can see what's happened. As we asked, the carbon emissions have been driven down from 6.2 to 4.4 million tons. But our cost has become very high. So at the moment, remember, cost is just reporting that as a consequence, and that's gone really high. So this is the other extreme. So a minimum carbon network, and what's the impact on cost? Of course, this is not a great result, because with a cost increase like that, it puts us out of business. So what's important with this functionality is that you can also put constraints on those increases. So my next step will be to say, well, let's put in a constraint of 200 million euros on the total cost for the supply chain. And I'm going to push the solve button again and let that solve. And what it's asking for now is a minimum carbon network, but subject to a constraint of not letting the cost increase from more than the original 191 million to more than 200 million. So let's give that a couple of seconds to solve. So that scenario is now solved, and we can see what's happened. So the carbon's gone up a little bit. So it's still trying to minimize carbon, but that's gone up from 4.4 to 4.6 because we've put a constraint on the total cost increase. And we can see that in the solution, the total cost increase is limited to that capacity that we specified. So this is a much better solution, and this is an example of how you can find that sweet spot, not necessarily on either of the extremes, min cost or min carbon, but somewhere in the middle where you get a big hit on carbon emissions, but without a massive increase in cost. What you can, of course, also do is include both carbon and cost in a single objective function. So I'm going to firstly select all four of these KPIs or objectives into my objective function. I'm going to remove that maximum capacity constraint. What I need to do now is make an assumption on the weight factor of how heavily I want to weight these different KPIs in this combined objective function. So in the cost carbon scenario, that's basically making an assumption on the carbon pricing. So if I put in 60 here, it means that I value 1 ton of carbon emissions at 60 euros per ton. And then I can optimize again for this scenario to see what the result would be. So that scenario is solved, and you can see what the impact is now. So the carbon's gone up slightly to 4.497. Total cost is also still around the 200 million mark at about 201. So this is an example of combining those different units of measures in one objective function. So what you've seen here is the ability to run these multiple scenarios to try and evaluate what's the best way to make these trade-offs using constraints and different objectives. And you can do that for the overall network. You can also do it per geography or per activity type or by mode of transport. So really lots of options to run these various scenarios and compare them. Of course, once you've run these multiple scenarios, you also want to be able to compare them. So within the application, you've got the ability to save these scenarios and compare them. So for example, in this screen here, side by side, I'm seeing the implications on the map. So over on the right in the min cost network, I'm doing a lot of long-haul secondary delivery into Iberia and North Africa from France. That's the lowest cost option. But over in the low carbon option is deciding to trunk into a DC in Madrid and do those secondary deliveries from there. So a different logistics pattern depending on which objective you're looking for. So visually, you can start seeing what the impacts are of these different trade-offs. You can also start comparing the different cost buckets to see where those changes happen when you're moving from minimum cost to min carbon and vice versa.